Welcome to Brain Vision.
This is an interesting problem. It's a collision problem. So we're given an intersection that's running west-east on one direction, and then it's running north-south in another direction. We have two cars, car A. So this is what happens before. So car A with the mass of we're given the mass of car A happens to be um, so we're going to have to get the mass of this. So the mass of car A happens to be 2,000 kilograms. This is 2,000 kilograms mass of car A, and it's moving in the x direction. So initial velocity of A in the x direction happens to be um, uh, we don't know what that initial velocity is in the x direction. We do know that the initial velocity in the y direction is 0 meters per second because it's moving from west to east. So this is kind of like in the positive direction, if you want to think of it that way. And then we have another car. We're given car B that's moving. So car A is moving west to east, and then car B is moving from north to south. Okay, it's moving from north to south. So you can have conventions where north-south can be negative, for example, if you want, and that's just fine. We could say if you're going downwards, that's negative. If you're going to the right, that's positive. If you're going upwards, that's positive. If you're going to the left, that's negative. So those are conventions you can use. And then the mass of B happens to be given as 1,500 kilograms. The initial velocity of B in the x direction happens to be 0 because it's not moving in the x direction, it's moving north-south. And then the final velocity, or rather the initial velocity of B in the y direction, that's kind of what's given, happens to be, if you say downwards is negative, so that's going to be north-south negative 15 meters per second. That's the information we were given before. And then afterwards, what's going to happen is the two cars will collide at the intersection, A and B. This is A, this is B. And then they're going to move a certain direction. So this is 65 degrees. This is east. This is west. This is north. This is south. So they'll have a final common velocity, which we call V final. And that V final common velocity has component vectors. So the downward component vector would be V final sine of 65, as you can see, because it's opposite the angle 65, and then the same V final in the x direction will be V final cosine of 65. Okay, so those are some things we're given, and we want to find out in part A what's V final, what's this final velocity, combined velocity after they collide. And then we also want to find out the initial velocity in the x direction for A, okay, velocity of A just before collision. Assume we have limited friction and we're using the laws of conservation of momentum. So in part A, the initial momentum equals to the final momentum. We want to find the initial velocity. So initial momentum in the x, we'll start with the x direction. Okay, we'll use the x direction to find the final velocity. So the initial momentum in the x would be the mass of A times the initial velocity of A in the x plus the mass of B times the initial velocity of B in the x. When they stick together, their masses combined as a sum, and they have a common velocity in the x, which happens to be V final sine of 65. So this is what we're looking for, the V final. So you could see the V final is equivalent to the mass of A, velocity of A in the x, plus mass of B, velocity of B in the x, all over mass of A plus mass of B, sine of 65. This is going to be sine of 65. We plug in the numbers, we get to see that the mass of A going back is 2,000 kilograms. 2,000 kilograms, and then the velocity of A in the x is we're using the velocity of so mass of A. Maybe we should use Y for this one. So 2,000 kilograms, mass of A. Sorry, we have to do in the Y direction, not the X direction, because we don't have the initial velocity of B. No, we don't have the initial velocity of A. You can see we don't have this one. So we have to go back and do it in the Y direction. So we're saying initial velocity in the Y direction. Okay, so this is not X, but we are going to do Y. And of course, it makes sense for the Y to be signed. You could see that. So the Y sign, that's what we're going to use. We just don't have the subscripts for Y right here. So we should change that. So initial velocity of A in the Y. So this is not the X direction, but this is the Y direction, just recall. So this is Y, and this is Y, and this is sine of 65. And then also we have initial velocity Y, initial velocity Y of B. And so this is 2,000 kilogram. Initial velocity of A in the Y direction is 0 meters per second. So, that's how we're doing this one. And then we add it to the mass of B, which happens to be 1,500 kilograms. Don't forget the kilogram right there. 1,500 kilograms times the initial velocity of B in the Y direction, and that happens to be negative 15 meters per second. And the negative sign, that just helps us determine the direction, what the direction is. And then the mass of A, 2,000 kilograms, plus the mass of B, which is 1,500 kilograms. Okay, and then times sine of 65. And so something you want to know is that when you plug in the numbers, you'll be able to get the V final, which happens to be 70, not 70, but 7.1 meters per second. So this is V final, 7.1 meters per second. So in this case, the reason why, in fact, we don't even have to use the minus. So this minus, we don't have to use this minus right here. I think we're comfortable. We just know the direction. Let's think about the direction: east, west, north, south. So you don't have to use those signs as we've done right and left before. So coming back, we see that the final velocity is 7.1 meters per second. And then the second part of the problem, we want to find the initial velocity, if you call it this one right here, initial velocity of A. And that's what we want to find, that one, VAIX. So we want to find the initial velocity of A, which we're calling VAIX. So we're going to use the x direction formula. Now we're dealing with x direction, and so we're saying the initial momentum in the x. Here we use the initial momentum in the y direction, just to be clear about that. Now we're saying initial momentum in the x direction equals to the final momentum in the x direction. Initial momentum in the x direction is mass of A times velocity of A, initial velocity of A in the x direction, plus mass of B times initial velocity of B in the x direction. When they stick together, we have mass of A plus mass of B, but now we're dealing with the x direction. On this side, you see we had velocity y, and then this one was our if you go back to the diagram, V final sine 65, that you could call that V of f of y, and then this one is a V of f of x. So we're going to use V of f of x, which is V cosine of 65. V cosine of 65. We already have V from the previous problem, which we call V final, right here. That's our V final. So we're in good shape. We want to solve for the initial velocity of A in the x direction. When we simplify that problem, we get initial velocity of A in the x direction is ma plus mb, V final, cosine 65, and then minus mv, vb initial in the x, all over the mass of A. We plug in the numbers. Mass of A is 2,000 kilograms. So we have 2,000 kilograms times, or rather plus, 1,500 kilograms times 7.1 meters per second, cosine 65, minus mass of B is 1,500 kilograms. But remember, the initial velocity of B in the x direction happens to be 0. So that just means that we're not going to have any momentum in that instance. We have to divide all of that by the mass of A, which happens to be 2,000 kilograms. When you simplify that problem, you end up getting that velocity to be 5.25 meters per second. So this is velocity of A in the x direction, happens to be 5.25 meters per second, initial velocity of A in the x direction. Hope you enjoyed the problem. We had to find the V final velocity when they meet in the intersection and they collide, and that's the number we had. And then we also had to find the initial velocity of A just before the collision. Okay, so if you have any questions, feel free to send them my way, and have a wonderful day. Okay, thanks. Bye.